Okay, this is a talk on an introduction to low trust protocols and Bitcoin's ability to facilitate autonomous agents. I gave this talk at the Stellenbosch Bitcoin meetup. If you don't know where Stellenbosch is, it's close to Cape Town in South Africa. Okay, so to start off, I think one of the more important things is to recognize the people that have made a lot of contributions in this area, especially the people in the Bitcoin community that have been thinking up some of these ideas and contributing. And as you can see, people like Mike Hearn, Jeff Garzik, Gregory Maxwell, Peter Todd, and so forth. There's a lot of them, and I thank everyone for their contributions. Okay, so let me start off by talking about the future. We all know that software is eating the world. It's creating entirely new and emergent systems. We look at things like the way in which we are capable of developing an online encyclopedias that are editable by anyone. We are capable of building immense open source projects through services like GitHub and distributed version control systems. And it's exciting to see because these sort of new emergent networks replace these old pyramid hierarchies that that make life a bit more efficient and the way in which we interact now in this new digital age. The question is, can we design more efficient systems? And if so, what will it look like? What will enable this? And one of the things that I think will bring about a very exciting new thought paradigm is if we can develop programs on machines and give them more autonomy, would this lead to more efficient systems? And I think the answer is a definite yes. I think the answer is definite yes because if we think about the way in which current systems are being run, people are most likely needed into the equation, and if people sometimes bring about this need, or not necessarily need, but they bring about factors that can be mitigated through autonomous systems. Things like people that are corrupt or the need to create profit-seeking enterprises. So I think in the future we'll definitely see the concept, and I think it's a very exciting concept to explore, the idea that we can create systems where programs and machines work autonomously. The question is, if we say that programs and machines create new and exciting systems, if they were allowed to function more autonomously, what's needed in this space? One of the most important things that is needed is the ability for programs to transact freely with people and with other programs. With Bitcoin, what it brings along is this idea that you can create a way in which programs can transact with each other. One of the other definitions of Bitcoin is the idea that you have programmable money, which is inherent to the digital world. And I'll explain later why more in depth about how Bitcoin can help and facilitate this new and exciting idea. But to start off, I just want to talk about what's the idea behind a low trust protocol, or why it's needed in the first place. So the idea behind a low trust protocol is the concept that two entities, whether it people, organizations, or machines, can transact with each other without requiring some upfront knowledge or some leap of faith. If you look at the Wikipedia article for trust, you'll see they used these following terms, which indicate there's sort of the idea of abandoning control between two entities. If I trust another person, there's an inherent risk that the person will fulfill the service or fulfill what they need to do. You see the quote that says, the uncertainty involves the risk of failure or harm to the truster. The trustee will not behave as desired. So there's this concept that trust is needed in some interactions because there's no way to make it happen in any other way. The idea behind low trust protocols is that they are there are certain interactions that we can create to reduce the need for trust, or reduce this idea that there's upfront knowledge required, that there's a leap of faith required. And the inherent usefulness of low trust protocols is that you don't have the overhead of having to rely on trust. There's no risk, or there's a lot less risk involved, which means it creates an immediately more efficient systems. One of the reasons why we have centralized or pyramid type systems is based on this, that there's no easy way for people to interact without requiring trust. And you can actually see this now on the internet, where in the past few years, because people have Facebook profiles, you could immediately trust people more over the internet. But before that, there was sort of this difficult gap that had to be solved between people for them to rent their apartments to strangers. So I think one of to explain this a bit better is to look at examples. And before going into programs, there's if you look at human history, there's actually been examples where interactions were initially used for the purpose of getting people to interact with each other without requiring some leap of faith or upfront knowledge. That little amount of trust was required. And the first one is the example of the handshake. As the story goes, the origin of the handshake is the idea that people could interact with each other by showing that by interacting with each other, that shows that they don't show some malintent or intent to harm. The idea behind the handshake is that you would walk up to a person and reveal that you're not holding a weapon. So in a way, you could interact with a stranger and then through that interaction get to a point where you don't need a lot of trust, and in that process actually create trust, or there's no need for trust. If you're in a handshake with someone, you're also in a very vulnerable position for both parties. The other example in history is the toast or the cheers. I did some research on this, and apparently it's still up for debate if this was actually ever the case. But I still think it's a good example of a low trust interaction between people that could bring people together. So the idea behind the cheers or toast was that if I wanted to poison you, through the process of cheersing, my beer would spill over into your beer, and then your beer would spill over into mine, then we would both be poisoned. So there's this idea that if people came together and cheers their mugs, there would be an immediate connection that didn't require some wishy-washy determined concept of who this person is, or if you could trust them or not. Now, looking at programs, the current way in which we establish services between programs, or the way in which one program can trust the other, is there's no protocol currently, or to my mind, that fulfills this entirely, because there's one reason why. People fulfill the role as arbiters of trust between two programs. And here's the perfect example. I write a program that connects to AWS. It hosts files on S3. But the program is blind in this process. There's no way for the program to know or infer in any kind of way if AWS would just disappear with the files. The only way the program can do this is because I am the inferer of trust. I am the determiner of trust. I look at Amazon and say they won't disappear with my money. They won't disappear with the money or the files or whatever. So I am the person in this process of two programs interacting with each other that is the determiner of trust. So if you look at it this way, programs work with each other. I would still rely people in this process. Like I said previously, people are the determiner of trustworthiness. And the other thing is, people also pay the bills. We have the credit cards, we have the bank accounts, and that's how it's always been. At the end of the day, in order for programs to interact with each other in a way that currently works, is people fulfill a role of intermediaries and the facilitators. The question now is, if we look at the way in which programs can, we want to design systems where programs can work with each other without requiring humans as this sort of intermediary step, because that would create this idea of a more autonomous systems where programs can fulfill more emergent and new uses for humanity. And if you look at Bitcoin, some of the slogans used for Bitcoin is as follows. One of the slogans were, "In Bitcoin we trust," or the other one is "Virus in numerous," which means strength in numbers, or in another way, there's security in the way in which it was designed. And the reason why Bitcoin helps in this way is that there's this verifiable low trust protocol for financial transactions that doesn't require some leap of faith or upfront knowledge for financial transactions to flow through it. So I can trust Bitcoin because I look at it and say this is a very cryptographically secure method of transferring value, and a program can verify the shared ledger in a cryptographic way as well and say this looks secure. So Bitcoin itself is a financially viable way in which to channel through value, but the problem though is the current way in which Bitcoin works, it is inherently like cash. It's non-refundable. It's not like a credit card. If you give someone your cash in the street, they can run off and you'll have no recourse. In the physical world, however, there's still some recourse involved in this process, which means that if a thief steals your wallet, you can still run after them and tackle them. The problem with the digital realm is that there's still some kind of higher trust required, and especially Bitcoin, due to there being no recourse. The only way I can trust a site to fulfill its service is I still have to be the person that infers its trustworthiness. So I look at, for example, a site that I can pay to download a file in Bitcoin. The only way I can know that they won't disappear with my money and not give me the file is to look at the site and somehow figure out that this seems trustworthy. It seems trustworthy, and it ends with the way in which credit cards work, because credit cards, as you know, can provide chargebacks. If you look at if I look at transactions and I say this seems like a risky thing to pay for, I would rather use a credit card because I still have the option of getting back my money. So a low trust protocol, and as you can see here, there's been examples of the high risk nature of the current Bitcoin space. Is, as you can see, it's been hacked consistently. So developing low trust protocols for financial interactions is beneficial in a few ways, and it's not just beneficial for programs. If I can pay for something with Bitcoin and I know I will get my service where I don't have to infer trust, it's beneficial for me. But more specifically, it opens up a exciting new space for programs to interact with other programs in a financial manner that doesn't require people. So you have immediate recourse for both. There needs to be a way that there has to be immediate recourse for both parties, that there's no leap of faith required, there's no upfront knowledge required, and there's no need for a human to arbitrate the trust between two services. Okay, so what are examples of these kind of protocols, low trust protocols? You can go check up on the Bitcoin Wiki, another page called contracts, and some of these examples are things like, and they exist in the current financial system as well, as things like escrow, deposits, and fidelity bonds. It comes down to the idea that you can use the Bitcoin blockchain to facilitate these transactions without needing another intermediary or a centralized third party. Because usually with escrow services at the moment, you still need two persons need to trust one other service to fulfill the role of the escrow. You could still have a case where the partner, the people that come together to trust the escrow third party can still run away with the money. So The one that I'm excited about in terms of getting programs to work together is the use of micropayment channels, or the general word is channels. I like to use the word streaming payments as well. And the idea behind is that you use this as an extended handshake to fulfill services as it happens. So you could pay for something per kilobyte. For example, you're at a coffee shop and you want some Wi-Fi, and you pay per kilobyte of download. Or, for example, you pay per minute for the file you host, or you pay per second for something else. Or, as a friend suggested, you can even go very small and say you pay per CPU cycle that you rent from another computer. So to explain how channels work, going to be a bit more technical now, but the idea is that if you know how the Bitcoin infrastructure works, is a client comes to and wants a service from a server. So it comes and knows that the server is the kind of service that fulfills that need. The client comes and put coins into a pot that both parties control, and then a refund transaction is created that sends all the coins back to the client with the a time limit, which is currently the default is 24 hours. I'll explain why this is important just now. So the idea is then when a server and a client interacts, they continuously update and sign a refund transaction that spends some of the coins differently. So the idea is that as time goes on, the refund transaction to the client gets smaller and the server gets more of the chunk that needs to be paid. When it's done, instead of having to flood the Bitcoin network with all these small payments, the refund transaction is then at the end when the service is fulfilled or there's an error in the thing, the refund transaction is broadcast. It provides a awesome way in which you could pay for something per increment of usage. But the cool thing is as well is that it serves as a way to keep a client and a server honest while the service is being fulfilled. If you look at it this way, say I have a payment channel open and you are downloading a file and you're paying per kilobyte, say you have a Wi-Fi connection. If the server disappears, the thing that provides the service, the client's already paid and received for the service up to that point. If the client misbehaves, the server can simply sever the connection and not interact with the client anymore. The server got what it provided, the client paid for what it got. And this where the final part comes in. If a client connects and puts this money up into this pot, if nothing happens, the client gets a full refund after 24 hours because the refund transaction has been created along with this multi-signature transaction. So during this process of creating this refund transaction, another important part is needed in a way to check that both are being honest, and it depends on the use case. So for example, if you're working with files, you can do things like hash challenges to make sure it's still the same file, that junk isn't being served, and so forth. But the important part is that you can now have this idea of two entities or two programs interacting with each other. It requires no upfront knowledge of the service's repeatability or its or where they can fulfill the service. There's no leap of faith required. The client pays for each increment of usage, and at the end of the day, there's recourse for both client and server. Yes, so I'll give an example of a micropayment channel prototype that Mike Hearn has developed. I have been working on it as well, adding improvements, some bug fixes, and adding new features. So the idea behind PayFile is a proof of concept of micropayment channels in which you could pay per increment, pay for a file you're downloading where I don't have to trust the server beforehand. So I could go to any dodgy site and realize, okay, they're using the software. I don't have to trust them to be repeated. The other thing as well is, of course, the cool factor that you're paying per kilobyte of download. So here's an example. These are some files in my download folder. I'm busy with the testnet is decreasing. So during this now, during this process, the client and server is interacting this whole time, and per each chunk of data that's being downloaded, it's interacting and talking to each other. A bit slow. I'm running a lot of programs. So yes, at the end of this process, the file's been successfully downloaded. I paid for the service that I got, which was paying for increment of usage, and the server got what it's paid for, which was delivering the files. So that's one of the examples, and you can see why this is useful for people, because we don't have to trust services anymore that that's going to run away with our money, and we can use Bitcoin and don't have to use credit cards. And the other thing that's the more important part is programs can now use this protocol to download files from somewhere, and once again don't have to trust the server to comply, because the server will be kept honest. In this space, looking at the future of autonomous agents, there's a lot of pieces that are to fit together for these programs to be to function autonomously, and there are things like having capability of low trust storage, having things like renting CPU cycles, paying for CPU cycles, low trust energy transfer, low trust bandwidth usage, low trust hosting environments, etc., etc. So it's a very exciting space to work with, and I think the future is more and more going to allow these type of services, because at the end of the day, we are going to see, if we allow programs to function more autonomously, we can see much more exciting systems. It comes back to the initial point that I made in the beginning. Is why low trust protocols? Why make autonomous agents? The thing that happens at the end of the day is that if we can create low trust protocols in general, it allows common problems to be solved in a way that minimizes the overhead of trust. Minimal trust often makes things more convenient by allowing human judgments to be taken out of the loop, thus allowing complete automation. To conclude, we can now design protocols and systems in which programs can interact on an equal level to humans. They can transact with each other equally and transact on an equal level with humans, creating this idea of autonomous agents and programs and machines, which give rise to exciting new and emergent behavior that will hopefully improve humanity for everyone. Thank you.